volume of combination of solids. Learning area, volume. Look at this water tank. How much water can it hold? How do you find it? The water tank is in the shape of a cylinder. So, by finding the volume of the tank, we can find the amount of water it can hold. Thus, we can define the volume as a measure of the amount of space inside of a solid figure. Using this concept, we find the volume of combination of solids, frustum of a cone in this lesson. At the end of this lesson, the students will be able to find volume of combination of solid shapes, know converting a solid from one shape to another, know about frustum of a cone. Let us recall the definition of volume. The volume is a measure of the amount of space inside the figure. Here, we shall see how to calculate volumes of a combination of two basic solids. The volume of the solid formed by joining two basic solids will actually be the sum of the volumes of the constituents. Mukesh runs an industry in a shed which is in the shape of a cuboid surmounted by a half cylinder. If the base of the shed is of dimension 7 meters into 15 meters and the height of the cuboidal portion is 8 meters, find the volume of air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meters cube and there are 20 workers, each of whom occupies about 0.08 meter cube space on an average. Then, how much air is in the shed? The volume of air inside the shed when there are no people or machinery is given by the volume of air inside the cuboid and inside the half cylinder taken together. Now, the length, breadth and height of the cuboid are 15 meters, 7 meters and 8 meters respectively. Also, the diameter of the half cylinder is 7 meters and its height is 15 meters. So, the required volume is equal to volume of the cuboid plus half of the volume of the cylinder. By substituting the values, we get the volume is equal to 1128.75 meters cube. Next, the total space occupied by the machinery is equal to 300 meters cube and the total space occupied by the workers is equal to 20 times 0.08, which is equal to 1.6 meter cube. Therefore, the volume of the air when there are machinery and workers is equal to 1128.75 minus 300 plus 1.6, which is equal to 827.15 meters cube. A solid toy is in the form of a hemisphere surmounted by a right circular cone. The height of the cone is 2 centimeters and the diameter of the base is 4 centimeters. Determine the volume of the toy. If a right circular cylinder circumscribes the toy, find the difference of the volumes of the cylinder and the toy. Take pi is equal to 3.14. Let BPC be the hemisphere and ABC be the cone standing on the base of the hemisphere. The radius BO of the hemisphere as well as of the cone is equal to 2 centimeters. The height of the cone is equal to 2 centimeters. Volume of the toy is the sum of the volumes of the cone and the hemisphere. That is equal to 2 by 3 pi r cube plus 1 by 3 pi r square times h. By substituting the values of radius and height, we get 2 by 3 into 3.14 into 2 cube plus 1 by 3 into 3.14 into 2 square into 2. Simplifying it, we get volume as 25.12 centimeters cube. Now, let the right circular cylinder EFGH circumscribe the given solid. The radius of the base of the right circular cylinder is equal to HP is equal to BO is equal to 2 centimeters. Its height is EH, that is AO plus OP. It is equal to 2 plus 2, which is 4 centimeters. So, the difference of the volumes of the cylinder and the toy is equal to volume of the right circular cylinder minus volume of the toy. Substituting the values and simplifying it, we get 25.12 as the answer. Hence, the required difference of the two volumes is equal to 25.12 centimeters cube. Now, let us see conversion of solid from one shape to another. Hope you would have seen candles. Generally, they are in the shape of a cylinder. There are also some candles shaped like an animal. Have you wondered how they are made? The candle is taken in the shape of a solid cylinder. It is heated in a metal container till it becomes liquid. Then, it is poured into another container which has a special shape like a rabbit. On cooling, it is obtained a candle in the shape of the rabbit. The volume of the new candle will be the same as the volume of the earlier candle. This is what we have to remember when we come across objects which are converted from one shape to another, or when a liquid which originally filled one container of a particular shape is poured into another container of a different shape or size. Let us look at some examples to understand what we have discussed. A cone of height 24 centimeters and radius of base 6 centimeters is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Given that radius of the cone is 6 centimeters and the height is 24 centimeters, volume of cone is 1 by 3 pi r square h. It is equal to 1 by 3 pi into 6 into 6 into 24. If r is the radius of the sphere, then its volume is 4 by 3 pi r cube. Since the volume of clay in the form of the cone and the sphere remains the same, we have 4 by 3 pi r cube is equal to 1 by 3 times pi times 6 square times 24. Simplifying it, we get r is equal to 6 centimeters. Therefore, the radius of the sphere is 6 centimeters. Devi's house has an overhead tank in the shape of a cylinder. This is filled with pumping water from a sump like an underground tank, which is in the shape of a cuboid. The sump has dimensions 1.57 meters into 1.44 meters into 95 centimeters. The overhead tank has its radius 60 centimeters and height 95 centimeters. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Compare the capacity of the tank with that of the sump. Use pi is equal to 3.14. Volume of water in the overhead tank equals the volume of the water removed from the sump. Now, the volume of water in the overhead tank cylinder is equal to pi r square times h. It is equal to 3.14 times 0.6 square times 0.95 meter cube. The volume of water in the sump when full is equal to L times B times H. It is equal to 1.57 times 1.44 times 0.95 meter cube. The volume of water left in the sump after filling the tank is found by subtracting volume of water in the overhead tank from the volume of water in the sump when full. Thus, it is equal to 1.07388 meter cube. That is 1.07388 divided by 1.57 times 1.44. It is equal to 0.475 meters. That is 47.5 centimeters. Also, capacity of tank to that of sump is 1/2. Therefore, the capacity of the tank is half the capacity of the sump.